Good evening, students. So now let's start our discussion. So I hope all of you are able to view the screen, correct? Could you please confirm that you are able to view the screen?
No, sir.
Not able to view? Okay, just a minute.
No, sir.
Okay. Yeah. I'm here to share with you. What about now? Not able to view?
Sir,
Sure, I can see.
it's visible, sir.
I can see.
It's visible, sir.
All of you are able to view it?
Yes, sir.
Yes, sir.
Okay, great. So that is the first question, descriptive question from laws of motion. So what is the answers you got, dear student?
I have a doubt in this question, sir.
Okay, we'll discuss definitely. But what about others? Pratik, Shrest? Okay, let's discuss. Now, if you look into this one, according to the question, okay, we need to find, the acceleration of the bodies A and B and the tension in the cable due to application of 300 Newton force. So now, here we need to apply the concept of constraint relation. So let's assume that let AB be the acceleration of the block B. So the block B is moving with an acceleration. So let's assume it is AB. Correct, no, dear students? So that is the acceleration, and towards right, definitely it should be towards right. And acceleration of the block A towards left B, AA. So that is, AA, subscript capital A, I'm writing. A for acceleration. Now, what is the, constraint relation? So if you apply the constraint relation, so that says that, that 3 into, if you look into it, that 3 into AB, okay, is equal to 2 into A, because if you understand the constant relation, so 3 into AB is equal to 2 into AA. Just give me a second. Okay, so now what happened is that if you look into it, so all of you understand what is constant relation, right? And if we apply this one, what we get the acceleration. So what we get from here, that AA is equal to 3 by 2 into AB, 3 by 2 into AB. Now, the point is that now how we can find the value of AA. So what is that? If you see, it is a 300 Newton force and total is coming as 3T, correct? And this is one thing we get. And another point, what we can find out is that 300 Newton minus 3T should be equal to 35 into AB. Correct or not? Force is equal to mass into acceleration. So what we get? 300 minus 32 is equal to 35, baby. Now, so from here what we get, this is one point, this is one equation we get. The first equation we get this one, second equation we get this one, and the third equation what we are going to get is that 2t is equal to 70 into AA. 2t is equal to 70 into AA. So from here what we can get is that, so now you solve all these three. You can solve and you can let me know what are the values of accelerations you are getting, and the the another part is that what is the the tension in the cable. All right. So if you do you want to find out values of this acceleration quickly? Hello. Could you please find the acceleration? Shrest, Pratik, Tejas.
Sir, acceleration of A is minus 2.34.
Yeah, correct.
Acceleration of B is 1.56.
Correct.
Tension is 81.8.
Fantastic. Very well. You found it very well. So if you solve these things, so then the value of, you got it in the initially, right? So, and you don't need to say negative because the direction is given. You can always find the value of, if you solve all this, you find the value of the acceleration AA is equal to 2.34 meter per second square, and the value of acceleration AB is equal to 1. I got 558, sorry, 56 also you can write, 558 meter per second square. And if you find the value of tension, the tension will be 81.8 Newton. Dear stressed, you get the same thing? Tejas?
Yes, sir.
Tejas, you understood?
Yes, sir.
Okay, good. So now let's proceed to the next question. And next question, let me pull that question for you first. Okay, so you got that one, Pratik? Who got this one? Shreyas, Pratik, Tejas, you can let me know.
Sir, I didn't get this.
Okay, definitely, I'll assist you. Okay, now, hello Tejas, Tejas and Shrest, you got it or not? Okay, hello, you should answer.
I didn't get it.
We didn't get it. What about Shrest? Hello Shrest? Okay, so let me start discussion. So, if you look into it, that let the mass of the man be m and the basket be, small m. Correct? Okay. So if I draw the diagram, so it should be something like this. So let me draw the diagram first. So first you look into it, that represents the problem. Let the picture come. Okay, let the picture come. Sorry, just give me a minute, please. Yeah. So if you see, there is a single pulley suspended from an overhead beam. Over it passes a rope, one end of which supports a basket in which the man stands. Okay, so it should be OF off. Okay, he pulls the other end of the rope and slowly lifts himself up. The man has a mass 60 kg. Okay, the efficiency of the pulley is 80%, and we need to calculate the man's pull on the rope in Newton. So this is the diagram I can think of. Hello, Shrest, you joined back.
Yes, sir.
Okay, so what's the value you got? I was asking this thing, so I didn't.
750.
Huh?
750.
You got the value as 750. Let's see.
वो चल नहीं रहा है.
Okay, let's see. Now let's analyze this problem. This is actually a very good problem. Okay. Now what we are assuming, let the mass of the man be capital M and that of the basket be lowercase m. Correct? And as you see, so mg is actually working here, this thing, and small mg is actually this one. Now let capital N be the reaction of the bottom of basket on man. Correct? Now F is the force exerted by the man. So that means F is the force exerted. Then what we can say? F plus N should be equal to M into G. Correct or not? So you understood what I'm talking about. That let N be the reaction of the basket of the man. Basket on man. Let N be the reaction of the basket on man. So what we are saying is that let N be the reaction of the N be the reaction of the bottom of basket on man. Bottom of basket on man. Then what we are going to get? And another thing we need to assume, and let F is the force exerted by the man. Let F is the force exerted by man. exerted by the man. Then what we are going to get? Definitely we are going to get F plus N is equal to M into G. And according to the question, we need to find the value of F, isn't it? So first thing what we get is that F plus N is equal to capital M into G. And that we can give as equation 1. Correct, no? The next one is that what we are going to get is that now if you look into the basket, so that is what we can find A plus N equal to mg when you look into the man. And once we look into the basket, there are 3 forces acting on it. One is the tension, capital T, the normal reaction, capital N, and the weight of the basket, that is lowercase m into g. So what we can get from here, we can get T is equal to capital N plus lowercase m into g. That is the second one. So now, what is, according to the question, the efficiency of the pulley is 80%. So what does it mean? Efficiency of the pulley is 80%. What does it mean? That means that output by input, that is equal to 80%. That means T by F is equal to 80 by 100. That implies output divided by input, that is equal to 80%. Now, as according to our assumption T and F, what we can say is that T by F is equal to 80 by 100. This implies T by F is equal to 80 by 100. Or we can say F is equal to 10T by 8. That implies F is equal to 10 into T divided by 8. So this we give equation number 3. So this by means of drawing this free body diagram, formation of the equations are important. Any questions so far? Please feel free to ask me if you have any smallest query here. Now, if we look into the equation number 1 and equation number 3, what we can write? Instead of F, we can write 10T by 8. So 10T by 8 plus N equal to 60 gram, because that is what is actually given. Correct? Huh? 60 kg actually. It is 60 into G, not gram. Sorry, I made a mistake. 60 into G it should be. So, from equation 1 and 3, from equation 1 and 3, we get what? We get, instead of F, we can write 10T by N, 10 into T divided by 8, not 10T by N, sorry, 10T by 8 plus N is equal to 60 into G, because M is 60 kg, so 60 into G. And from here we can find the value of 10T by 8 equal to 60 G minus N. So from here what we get is that 10 into T by 8 it equal to 60 into G minus N. So that we can give an equation number 4. Correct? Now let's look into equation number 2 and 4. In the equation number 2, it is written as T is equal to N plus mg. And equation number 4, we found that 10 by 8 into T is equal to 60 minus N. So what we are going to do here, let's add it so that we get that N get cancelled. So what we are going to do now, from equation 2 and 4, from equation 2 and 4, we get, so 1 plus 10 by 8 into t, that is equal to, in and in got cancelled, so we get 60g and 60g plus m into g, 60g plus m into g. Now if we look into the question, if we look into the question, then it is given that the efficiency of the pulley is 80%. So what we are going to get is that, just a minute, I need to look into it here. So the mass of the basket must be given, otherwise it is of no meaning. So what I see is that a basket, mass of the basket is actually 10 gram, let's assume. Okay, you got my point, dear students? So let's assume the mass of the basket be 10 kg actually, not 10 gram, 10 kg. So then lowercase m should be 10 into g. And from here, what will, let's assume that m is equal to, 10 kg. So from here, what we get? From here, what we are going to get is that 1 plus, 10 by 8 into t, that is 18 by 8 into t, 18 by 8 into t is equal to 70 into g. So from here, what we can do is that into 18 by 8 we can make it 9 by 4. So where can make 4, here it is 9. So from here we can find the value of t is equal to 70 into g, 9.8 meter per second square, into 4 divided by 9. Got it? 70 into 9.8, 9.8. Let me write properly. Yeah. So from here you find the value of tension, and as you find the value of tension, so if you that implies what is the value of A from equation 3? 10 by 8 into T. So it is 10 by 8 into 280 by 9, 280 by 9 into 9.8. So you don't need to waste time in calculating all this. So if you find it out, you will get 381 Newton. Dear stressed, you said something different, right?
Yes, sir.
But one thing is that you should have informed, because I made a small mistake here without informing the mass of the basket. Correct? No? Because
Yes, sir.
definitely it depends on the mass of the basket. The question is incomplete unless I say what is the mass of the basket. But most importantly, dear students, what is important here is to understand the that how to, from the word problem, how we can make a free body diagram, and from that free body diagram You see, when you take the fundamental principle of free body diagram, when you take only one object, we just concentrate on the forces acting on that particular object and do not concentrate on the others. Think about man is the object, then we concentrate the force acting on the man. What are the force acting on the man? Capital F, capital N, and its own weight, capital M into G. When you look into the basket, we see that there are three forces acting on that basket. One is capital T, one is capital N, that is the normal reaction, and and the M in lowercase m into G, that is the weight of the basket. And there are two equations we got, which we give an equation number 1 and 2. And then another point is that what is the efficiency of the pulley? Efficiency of the pulley tells that as it is 80%, that by giving a force of capital F, I am getting a output of capital T. So T by F equal to 80 by 100. So we get three equations. The moment we get these three equations, after that the problem doesn't belong to physics. It is just solving linear equations, which we have done in our class 9 standard. So if things are clear, Tejas, it is absolutely clear.
Yes, sir.
Okay, then we can proceed to the next question. Okay, so let me pull the next question and we will discuss accordingly. Sorry. So that was the descriptive question number 3. As you see, the question is in front of you. Now you can let me know what is the answer you got, dear student.
So, this one has a long answer.
Okay, long answer. Okay, what is that value?
It's like tension is equal to M1 M2 sine alpha minus beta divided by M1 cos alpha plus M2 cos beta.
Correct. Correct, you are. So you are saying that the tension, you got M1
Yes.
M2 into G into sine alpha minus beta by M1 cos alpha plus M2 cos beta.
Yes, sir.
Okay. What about you, Tejas and Shrestha and Pratik?
Sir, I didn't get, sir.
Okay, you didn't get it. Okay, we'll look into it. Dear Pratik.
Sir, I got M1 M2 sine alpha minus beta times G by M1 cos alpha by M plus M2 cos alpha or beta.
M2 cos beta. That is perfectly correct answer. Okay, so if you look into the diagram, dear Shrestha, what is mean? Two cubes of mass M1 and M2 lie on two frictionless slope of block A, frictionless slopes of block A, and rest on a horizontal table. Okay. The cubes are connected by the string which passes over a pulley, as you see in the adjoining diagram. To what horizontal acceleration A should the whole system be subjected so that the cubes do not slide down of the plane. And then that is the first part, and second part is that what is the tension in the string at that stage. So now the point is that, we need to find two things. The first thing is the acceleration. Okay, so suppose it is actually being moved with an acceleration of a. So we need to find two things. One is A and another one is the tension. Correct or not? Now, two angles has been given, alpha and beta, as you see. Okay. Now let's find out, what are the forces are acting. Let's concentrate on that mass m1. If we concentrate on the mass m1, okay, dear Shrestha, let's look into it. In the mass m1, what we are going to get? So the moment it is actually moving with an acceleration a, then you will find this is actually, there is a force acting on it like this, correct or not? And that should be m1 into a, correct or not? And as this angle is alpha, so what we will get? We will find a component of this thing along this is equal to m1g sine alpha. m1g sine alpha. And tension is there. So along with this tension, so in this, what will the force here acting on it? So tension T plus m1 into A into cos alpha. Correct or not? m1 into A into cos alpha. Because the component of the acceleration. Correct or not? So now, what we'll get? m1g sine alpha should be equal to T plus m1a cos alpha. So what we get? m1 into g into sine alpha is equal to T plus m1 into a into cos alpha. Correct or not, dear students? Shrestha, you got it? Now let's look into the other object, that m2. In case of m2 also, this will be m2 into a, and what we'll get is that the tension is this one. So what the force we will get it here? T plus m2g sine beta. T plus m2g sine beta, and along this direction, what we are going to get is that m2 into a into cos beta. m2 into a into cos beta. So again, if we equate all these things, what we'll get? m2 into g into sine beta, m2 into g into sine beta, that is equal to, that sine beta plus t, correct or not? m2 into g into sine beta plus capital T, that should be equal to m2 into a into cos beta. So this is equation number 2. Now we have two unknowns. First unknown is lowercase a, the acceleration, and second unknown is the capital T, the tension. We have two unknowns and two, equations. It is a linear equation.
Sir, I got it, sir.
Correct now. So
Yes,
exactly.
sir, I got.
Okay. So now if we solve it, I'm just writing it down. So by solving equation 1 and 2, by solving 1 and 2, we get a equal to Tejas and Pratik, you didn't answer the value of the acceleration. That is also part of the question. So it is m1 sine alpha plus m2 sine beta divided by m1 cos alpha plus m2 cos beta into g. That is the value of the acceleration. And the tension what we are going to get is that m1 m2 g into sine alpha minus beta, as you correctly said, Tejas and Pratik. m1 into m2 into g into sine alpha minus beta divided by m1 cos alpha plus m2 cos beta. m1 cos alpha plus m2 cos beta. I hope you got it. Any doubt at any moment of time, please. So here also, like the previous question, when you concentrate on the object M1, we are only concentrating the forces acting on that object M1. Forget about that M2. And when we are concentrating on the force acting on the object of mass M2, we are completely forgetting about what is happening on M1. And this is the fundamental principle when you draw the free body diagram and analyzing the forces acting on it. After that, the problem doesn't belong to physics. The problem actually belongs to mathematics. In this case, it is a linear equation of two variables. All right, so now we can proceed to the next question. That is descriptive question, 4. Now let me pull the question first, and then we'll have a discussion on that. Okay, a train moving up an incline 7 in 25. Okay, here also I got some doubt from some of you. In fact, from Thresk, you said that actually gives that what is the inclination, has an acceleration of g by 5 meter per second square. What will be the acceleration of the same train on a level road if it exerts the same traction force? The coefficient of friction mu between the road and the wheels is the same in both the cases and is equal to 0.2. Okay, so able to get it, or you need any assistance from me? Hello?
No, sir.
Okay, so let's first draw the diagram. Okay, so that will help us to understand the situation. Pratik, you got it or not?
Sir, can you explain that how to calculate a inclination angle?
Absolutely. It is more than.
Sir, I got it.
I'm sorry.
I got it, but you can explain.
Okay, fine. All right. So let me explain, and then you can verify whether whatever you get is coming to this or not. See, if we draw the if you see the adjoining diagram, whatever I'm seeing, that incline of 7 in 25. Okay, so that means it is sine theta is equal to 7 by 25. You may think, sir, how it is, because this is also another way of saying the inclination. So how it happens, when it is moving for uh, that 7, this one, then the hypotenuse is actually become 25. That is called 7 in 25. Got it, dear students? So if it is 25 hypotenuse and 7, so sine theta is equal to 7 by 25. Sine theta is equal to 7 by 25. Now the moment you get sine theta equal to 7 by 25, definitely we can get the cos theta is equal to 24 by 25. Dear students, did you get the point? Instead of saying that 7 by 25, I intentionally write the question like this. Okay?
Yes, sir. So I'll try to solve it and then again tell you the answer.
Definitely you can. But I can give you little hints so that all of you can, work on it. So if you look into the inclined plane, what are the forces acting on it? That is the traction force. What is that? Ft with subscript t. Okay. Then the weight of the train that has two components, as you see. One is mg sine theta along that inclined road. Okay. And there is a frictional force also. So what we get, if you look into this one from this inclined plane, the equation what we can form is that the traction force Ft minus m into g into sine theta, correct, and minus mu into mg into cos theta, minus mu into mg into cos theta. That actually is a resultant force acting on the train, which gives an acceleration a. So it should be m into a. Correct or not? So now here you need to find the traction force. So you can find that g is also given, and the value of sine theta. You can apply all these things and you will find the value of ft. And I just shared the answer with you. You can work on it. Okay, and you will find the value of ft is equal to, if you solve it, if you do not get it, please again do be in touch with me. You will get it is 16.8 divided by 25 mg. That is the value of the traction force. Now on the level ground, what happened is that on the level ground things are pretty simple. So that is in the inclined plane. Okay, and in the level ground what you will get is that ft minus mu mg is equal to ma. Ft minus mu mg, that is equal to m into a. That is quite simple. So that is in the inclined plane. Let me use a different color. It is in the level road. And this is in the inclined road. Now the point is that from here you can find the value of acceleration, because you already found the value of ft. So what we are going to get,
Sir, acceleration is g by 5, which is given.
I'm sorry. I'm talking about the here. Sorry, I made a small mistake. There is a different acceleration. So I assume it is a prime. We need to find the value of a prime, the acceleration of train on the level road. Correct, no? So a prime,
Yes.
you can find it out. Yes, a is given, but I'm talking about the a prime, which is the acceleration. Okay, uh, you know, uh, you know, of the same train on a level road that we assume as a prime, and the value of a prime you will get, if you compute 59 by 125 g. 59 divided by 125 g. Please work on this. So these are the two things we are supposed to find, and if you do not get this value, please be let me know. So with this note, can we move forward for the next question? Hello.
Yes, sir.
Okay. I'm sorry. This is also a very, good question. So this is descriptive question 5.
Sir, is it m omega r square cosec square theta?
Sir, is it m omega square r plus g cot theta by 2 pi?
Come again once more, Pratik, dear Pratik.
M omega square r plus mg cot theta by 2 pi.
Correct you are. Yeah, exactly correct. Shrest, you wanted to say the same thing or you said something different? Sorry, in case I missed it.
Sir, difference.
Different? Okay, okay, we'll look into it. No problem. Dear Tejas, able to do it or you need my assistance? Hello?
I got it, sir.
Okay, you got it. So, okay, let me explain. As Shrest, you got a different answer. Okay. So let's give a visual representation of the entire problem first, okay? And then we will discuss about it. So a chain of mass m moving in a circle of radius r, capital R, is slipped on a smooth round coin with half angle theta. Find the tension of the chain if it rotates with constant angular velocity omega about a vertical axis in coinciding with the symmetry axis of the cone. Absolutely, it should be coinciding. Okay. Now, if you see, sorry. Now the point is that if you look into the diagram, from this diagram, we can form equations. Again, from the diagram, we need to form the equations. So if you look into it, so what we'll get that, the first equation we are going to form is that it is 2t sine d phi by 2, 2t into sine d phi by 2, okay, minus dn cos theta that is equal to dm into omega square into r. So this is our first equation. And the second one is that dn sine theta is equal to dmg. So dn sine theta is equal to dmg, and this is our equation number 2. So what we need to do is that let's work on these two, and what we can write is that 2t sine d phi by 2 minus, if we apply the value of dn, so we'll get dm into g into cos theta by sine theta. So from these two equations, what we are going to get is that 2t into sine d phi by 2 minus dm into g into cot theta is equal to dm into omega square into r. So now the point is that what you can do is that, when d phi is very small, d phi by 2 is also very small, and for a very smaller angle, the sine of that angle equal to that angle. For example, sine 0. Sine 0 is what? 0, because 0 is a smaller value. Now if you take sine 001, that will also be near to 001. When it is very, very small, all of you got it, no? When you can also understand from the trigonometric functions. So if you look into the sine curve, how the sine curves looks like, it looks like this, no? So sine 0 is 0. So near to 0 in this region, the value of sine should be always very, very small, equal to the angle. So that approximation we can use it here. So if we apply that approximation, we are going to get 2t into d phi by 2. 2t into d phi by 2, that is equal to dm, we can take common, into what we are going to get is that g cot theta plus omega square into r. Sorry, omega square into r. So that means what we are going to get it is that t into d phi is equal to dm into g cot theta plus omega square into r. After that, from here what you can do is that what we are going to get is that we need to find the value of dm. Okay, and how to find the value of dm is that dm is equal to m by 2 pi r into d phi. Correct, no? So what we are going to get is that dm is equal to m by 2 pi r, because it is a radius of capital R, 2 pi r, into r into d phi. So that we can simplify little, and what we are going to get is that m by 2 pi into d phi, that is m by 2 pi into d phi. Now we can apply the value of d phi here and we can find the value of. So from here what we can get, the value of t is equal to mg by 2 pi. So m into g divided by 2 pi. The value of d we are getting now. So we are applying it here, by the way. So then d phi got cancelled. So m into g we are taking it out from here. Okay, and omega square into r by g. So as we are taking one g cot theta, that g will come out, and omega square r we can divide it by g. So what we are going to get? We are going to get is that cot theta plus omega square into r by g. And this is the answer, I think, what you said, Pratik. Okay. I hope you got it, dear students. And now we can work on the MCQ questions. So let me pull the MCQ questions and we will have our discussion after that. So what is the answer you got for this MCQ one?
Sir, D.
Sir, D.
Okay, great. Tejas, you also got D? Okay.
Yes, sir, I got 140 newtons.
Okay, great. So now let's go to the next one. Just a minute. So this is question number 2, MCQ 2. So what you got?
C.
Yes, sir, C.
Okay, wonderful.
C.
Great. C is the correct one. Then let me go to the next one. Okay, so let me pull both question number 3 and 4 together. So MCQ question number 3 and 4, as you see, dear students. Okay, sorry, let it come. Actually, it is taking some time to, yeah. So for the question number 3, what you got, dear students?
Yes, sir.
Huh? What you? Yes.
Option A.
D, sir.
I'm sorry.
So I got D. I got D, sir.
Okay, it is not D, it is A. You see, if you look into for the mass M1, okay, the equation what we get is that F equal to M into 12.
Okay.
Correct, na?
Yes, sir. Yes, sir.
And for the second one, what you get is that if you look into it, so how the forces are actually acting, I can show you the diagram here so that it will helpful to you to understand. Yeah. Correct, no? So what you get for the mass M1, what you get F equal to M into 12? Let me use a different color. Correct, no? For this one, what we are going to get is that F equal to M into 12. Correct or not?
Yes, sir.
And for this one, what we are going to get is that F is equal to M into 3.3. Correct? Clear or not clear?
Yes, sir.
Now here, for
Yes,
an
sir.
object whose mass is the difference between M1 and M2, what we are going to get? F is equal to M2 minus M1 into A1. So there, what you are going to get? F is equal to M2 minus M1 into A1. And from here, what we can find the value of A1 is equal to F by M2 minus M1. And F is already you are aware of. Okay. Or you can write the other way. M2 and M1 you can write in terms of F from these two equations. If you give this as equation 1 and if you give this as equation 2. So what we are going to
Yes.
get? A1 is equal to F by M2 is what? Oh, sorry, this is M1 and this is M2. F2 is what? M2 is what? F by 3.3
Yes, sir.
minus, here it is, F by 12. And if you compute all these things, you will get 4.55 meter per second square. Correct, no? Got it?
Yes, sir.
Okay. Now let's come to question number 4, dear students. What you got for question number 4?
Sir, C.
Sir, C.
Okay. All of you got C?
Yes, sir. C.
Okay, great. Fine. Now let me proceed to the next question. So here you see that question number 5 and 6 I brought together.
Sir, 5C.
I'm sorry.
Option C.
5 you got option C. All of you got, dear students?
Yes, sir.
Pratik?
Yes, sir.
Okay, great. I appreciate. Good. Very well done. And question number 6.
I got B, sir.
Sir, C.
What you got? No,
C.
it is not C.
Sir, D only I got.
Yeah, it is D. You know how it is D? Let me explain you, Pratik. Let F be the force applied by the monkey on the rope in the downward direction. Due to this, reaction T acts in the upward direction such that T is equal to F, correct or not? Correct or not? Let me use a different color. Correct or not? Let me repeat once more what I'm saying. Let A be the force applied by that, means capital F. Capital F be the force applied by the monkey on the rope in the downward direction. Due to this, the reaction T acts in the upward direction, and what we get, F is equal to T. So now, finally, what we can say, T minus mg is equal to ma. T minus m into g is equal to m into a. So that means what we can get, T is equal to m into sorry, g plus a. And if you apply all these values, you will get 165 Newton. Got it, no?
Yes, sir.
The force that should apply on the rope, the force that monkey should apply should be 165 Newton downward. Pratik, you got the point, right? Dear Pratik?
Yes, sir. I just got confused with the diagram.
Oh, okay, all right, that's fine. Okay, now let me bring the other questions. Okay, I hope you are able to view question number 7 and 8 in front of you, dear students.
Sir, B.
Yes, sir. B.
Question number 7, you got B. It is precisely the correct answer. Very good. Just you need to draw the free body diagram and solve it accordingly. And for question number 8, what you got?
A.
You got A.
Yes, sir.
Okay. Let's see. It is not A. Apparently, it looks like A, but it is actually B. So here you need to draw the free body diagram. Okay. So let's draw the free body diagram of the man. If you draw the free body diagram of the man, so it should looks like something like this. Okay. The diagram is okay. Let the diagram come. Just give me few seconds. Yeah, it came. So that is the free body diagram. Let AB be the upward force. So total mass of the system. Total mass of the system means total mass of the system. System means the man and the parachute is M plus MP. MP is the mass of the parachute. So according to the question, what we get, according to the question, it is given that M is equal to, 77 kg, correct? And MP is given as 5.2 kg. So then what we get is that 82.2 G minus FB is equal to 82.2 A. So from here what we are going to get is that FB is equal to 82.2 into G minus A. And if you compute all these things, you will get it actually 616.5 Newton. And hence we get the option B as the correct one. Any doubt? Any smallest doubt, dear students?
No, sir.
Okay. Now let me come to the next question. You will get question number 9 in front of you in few seconds.
Sir, D.
Yes, it is precisely the correct answer, D. I hope all of you got D. Hello?
Yes, sir.
Dear Shrest, you got D?
Sir, I didn't mark anything.
Okay, so here what happened is that there must be a pseudo force on the particle with respect to frame S1 or S2 or both, because one is accelerating with respect to the other. So option D is not possible. As simple as that. Correct or not? Dear Shrest?
Oh yes, sir. I didn't read the not possible case.
Oh, okay, okay. So that
I
is,
just
yeah, understood. That is one lessons learned, you know, that attention to detail is very important, because in the entrance exam, the questions, you know, that all the basic conditions always you need to, you know, give the corner cases, the word sentence that you should not actually ignore. That makes the, you know, meaning of that question completely different. Now let's come to question number 10. What you got, dear students? Question number 10.
Sir, D.
Are you sure?
Yes, sir.
Pratik and Tejesh?
D, sir.
It is actually, option is correct. Option is A. If you
Yes,
read,
sir, I got it.
yeah, exactly. So if you look into the problem, you know, and then you find the inherent meaning of it, what we conclude is that because elevator, and as it is elevator, hence the person. So because elevator, hence the person does not have any acceleration. Pseudo force is zero in both the cases. Hence, we get correct option as A for question number 10. Let's come to question number 11, dear students. What you got for question number 11?
Sir, I got C.
Sir, I also got C.
Are you sure?
Yes, sir.
No, yes, sir.
No, it is actually B. At any angle theta, when the body is not sliding, the frictional force is equal to mg sine theta. Correct or not? So if I draw the diagram, so what will happen? You will get something like this. Let me show you the diagram. Correct? So what I'm saying is that at any angle theta, when the body is not sliding, frictional force is equal to mg sine theta. So what will be the contact force then? The contact force should be square root of mg cos square theta plus mg sine square theta. Correct or not? That
Yes, sir.
contact force is equal to square root of m into g cos theta whole square. Pratik, you got it?
Yes, sir.
So that becomes cos square theta plus sin square theta equal to constant. No, so we get it is a constant. Dear stressed, you got it?
Sir, shouldn't be the contact force only be mg cos theta?
No,
Because that's the normal reaction.
nah. The point
Contact.
is that you look into a body is placed on a rough inclined plane of inclination theta. At the angle theta is inclined from 0 to and repose alpha, the contact force between the block and the plane, right? So from 0 to the angle of repose alpha, then what happened is that in context to the problem, the body is not sliding. The frictional force is equal to mg sin theta, na? What will be the contact force then? That will be the resultant of these two, right? Obviously. And that resultant force is actually constant.
Okay, sir.
Now let's come to the next, two problems. Just let me pull the questions first, dear student. Yep, tell me.
Sir, I think 12 is A.
What about stressed?
Sir, D.
Hmm?
D.
Correct, you are. It is D. Okay. Angle of repose does not depend on the mass of the body. Correct? And we get correct option as option D. Dear Pratik, is it fine?
Yes, sir.
Okay, now let's come to the next question, question number 13. Please do let me know, dear students.
Sir, is it C?
Not really.
Sir, B.
Yes, it is B. So let's understand. Okay, so what happened is that let me first, draw the diagram so that it will be helpful to understand. By the way, Tejas, what you got?
So 12 I got D.
Huh?
13 I got 12 I got D, 13 I got C.
Okay, let's see. Okay, so this is the diagram, right? Now the chain just began to slide off the table. Therefore, weight of the hanging chain should be equal to the frictional force between the chain and the table. Correct or not? Okay, let me write it down. The chain just begins to slide off the table. So the chain just begins to slide to slide off the table. Therefore, what we are going to get is that weight of hanging chain is equal to the frictional force between the chain and the table. Frictional. This you understood, dear students?
Yes, sir.
Between the chain and the table. Between the chain and the table. So what we can conclude from here? Now we can give a mathematical formulation for this statement, that weight of the hanging chain is equal to the frictional force between the chain and the table. So weight of the hanging chain will be what? M by L into NL into G. Correct or not? That should be equal to M by L into L into 1 minus N into G into mu. I hope it is self-explanatory. And from here, you find the value of mu is equal to N by 1 minus N. Eventually, we get the correct option as B. Shrest, please do let me know if something is not clear.
Sir, I got it, sir.
Okay, all right. So now let me bring the last two questions, dear students.
Sir, I couldn't get 14.
You didn't get?
Sir, is 14B.
Yes, correct. You are. 14 is B.
B.
Okay, let's discuss on question number 14. So, dear Shrest, so let's first draw the diagram. Okay, so that will help us to understand the problem in better. So this is what we can draw, right? Now the frictional force between the block A and B, I repeat, the frictional force between the blocks A and B is equal to, F is equal to mu into MA into G. Let me use a different color. Let me use the blue color. Okay, so let me pull it here a little bit. So that what I'm saying is that the frictional force between the block A and B, that is equal to F. F is equal to mu into MA into G. Correct or not, dear Shrest? And from here you can find it value because you know what is mu, what is MA, what is G, you can find it out. Now for the 200 gram block, what we can say, T minus F, I'm just giving you the hints. T minus F should be equal to MA into AA, correct? Mass of the object A and acceleration. So here you can find the value of F, you can apply the value of F, what we got in the previous step, and that you apply, and finally you will get the value of T. Correct or not? So from here, you can get the value of T is equal to, as I compute, 0.354 Newton. 0.354 Newton. For the 700 gram block, we have frictional force between the block B. We get the frictional force between the block B and the surface F1, and the surface, not F1, sorry. For the 700 gram block, we have frictional force between the block B and the surface. What we can find F1? What is that? We get F1 is equal to, let me write it. Okay, here, let me write here. F1 is equal to mu into MA plus MB into G. Correct or not? And that you can apply, you can find the value of F1. Now, finally, what we can conclude by looking into all these things, that capital F minus capital T, capital F minus capital T minus F minus F1, that should be equal to MA into A, that is equal to MB into AB, sorry. MB into AB, isn't it? Correct or not? Dear stressed. So if you apply all these things, the value of F you will get is equal to 2.18 Newton. Hence, we get the correct option as option B. Stressed, please do let me know. I gave you the hints, you can work on it, and in case of any difficulty, you can always contact me. Okay, now let me proceed to the next question, the last question for today's session, that is...
Sir, I'm getting some 1.9, some value, always.
Okay. We can compute it later because, okay, fine, na? Because this is some simplification. You can do one thing. Once our class is done, you do all the computation and send it to me. Correct, no?
Okay, sir.
Okay, all right. There must be some mistake is happening in the calculation. Now let's come to the last question, that is question number 15. What you got?
Sir, C.
Pratik, you got C. C is the correct answer. Pratik, you got C?
Yes, sir.
Okay, Tejas. Dear Tejas.
I got C, sir. I got C.
Okay, all right. So we are done. Now, my humble request is that, start solving as many as problem, from the online platform at KonarClasses.com. This is very important, dear students, as you also realize. So please do accordingly. And in the next class, we will, discuss a similar unit test on structure of atom. What do you think? Fair enough? Correct? All of you agree that we can solve a problem on, on structure of atom?
Yes, sir.
Okay,
Yes, sir.
All right. So I'll send you the unit test question paper. You can, download it from the app or from the online platform, and then we'll proceed. So with this note, I would like to conclude the class for today. Our next class is on day after tomorrow. You will get the class notes in another 15 minutes from now. Thank you very much.
Thank you, sir.